We're going to make a start now, and I think the next speaker is Professor Philip Beales. I don't think he requires much of an introduction, but for those families who are new, he, I guess, put Bardet-Biedl syndrome on the map medically in the late 90s, and he's going to give us an update on the research into Bardet-Biedl syndrome.
Thank you, Elizabeth. So, yes, I've been medical advisor since I was, I think, 14 years old. Thank you very much. Nice to see you all again. So, there's record attendances again here today. Could you put your hand up if you are new, this is your first visit? Wow, that is huge. Well, welcome. So what I traditionally do in this little round up here is just give a sort of a medical and scientific update, which will be a brief canter because this year Tonya's asked me to be brief. So she's reduced my slot to just 2 hours. But without any further ado, I'm going to begin by talking about the clinical service, and then we'll talk a little bit about the scientific areas, and then talk a little bit about some of the treatment opportunities that are coming our way. So I'm really grateful to a lot of the support staff from the various clinics, the 4 clinics, the 2 in Birmingham and the 2 in London, for coming today, and a lot of them are here. And I'm even more impressed that the lead clinicians for 2 of the centres, Great Ormond Street, Shella Mohammed, where is she? Could you stand up just to say hello? Yes? Guys. And for Birmingham Children's, Tim Barrett, stand up and wave. I've had too much beer last night, of course. So thank you. And so they will be around as well this afternoon to talk about various aspects of BBS in the clinics and so forth. But for those of you who are new, many of you, some of whom have been to clinics already or may be going to clinics, historically, we're really blessed that the NHS England, funded this clinic, a nationally specialised clinic, back in 2010. And it is formed of 6 parts, really. So there's 4 clinics that I told you about: Birmingham Children's, University Hospital, Queen Elizabeth Hospital, Birmingham, Guy's and St Thomas's Hospital in London, and Great Ormond Street Hospital in London also. So they're supported by the BBS UK, as we call it now, used to be called LMBBS, in a pretty unique partnership. There are very few of these services around the country whereby the patient support group has a direct third sector contract with NHS England, which is something we insisted on at the beginning of this, and that, to our mind, has worked extremely well and absolutely fundamental to the way these clinics are actually implemented, should I say. And then the 6th element is, which is also a first in the UK, is the DNA lab. So in other words, as we were developing the plans for this clinical service, there were genes popping up that were associated or causative for Bardet-Biedl syndrome. And what we wanted, because we were only doing them on a research basis and we were running out of money very fast, we wanted to move that into the NHS, and this was our opportunity. So through this mechanism, we were able to get the lab, which is the one based at Great Ormond Street Hospital, which is now a reference lab, not just for the UK, but also quite a lot of samples come in from Europe as well. That provides a really high quality service for the 21 genes that are now associated with Bardet-Biedl syndrome. Okay, so we have in total around 500 patients who attend all 4 of these clinics throughout the UK, and it's growing faster than we thought it would, and there are many reasons for that, which we can discuss this afternoon. But we had predicted there would be probably about 20 or so new patients a year. What we hear is that just in the last month alone, we've had about 17 new families already being presented. So that's an issue for us to worry about in terms of how we accommodate everybody. So I just want to very briefly share with you something that we've talked about on several occasions at past meetings, and that's the new patient management system that we've developed with a company, West Country company called Certus. And they've developed this system, which is like an electronic patient record, but is bespoke. It's customized just for you guys to be used at the 4 clinical centers as such. And the idea is that it will help us to implement the clinical care pathways, to record all of the activities, produce letters, and enable a more proactive level of care. That was the ultimate idea. So it will then provide not only clinicians anywhere across the world eventually, we'll come on to that in a moment, access to your information, but also eventually yourselves will be able to access that information as well. So I've just got a few screenshots here just to show you a glimpse of what we're able to do. It's a bit small and a bit crowded, but I will just briefly tell you what some of the tabs will show us. So obviously the first tab, we will be able to see everyone on that particular day who's come to that particular clinic. The names are listed at the top and I've blanked them out obviously. And we will see, if we click on any one particular patient, we can then see their summary data, which is going to be obviously their name, date of birth, address, who their parents are, and various other information. Then if we click on the next tab, there's a very helpful tab called the timeline. And this is going to be more valuable over time simply because when people have come to several clinics, we'll be able to go back and see all of the information that is related to that particular episode, that particular visit. So I've got listed here, which you won't be able to see, but we've got a picture of the genetic assessment, the speech and language assessment, the endocrine assessment, and so forth. And so what we can just simply do is click on the little file sign there, and it will bring up information about that particular visit, what was said by the dietitian on that particular day. So that's an immensely helpful to us. If we move on to the next tab, this shows us all the actions. So in other words, this is not only the types of actions around, say, ophthalmology, around genetic testing, around the appointment itself, but also it shows who might be responsible, or at least who created that particular episode, if you like. So at least we have a log, if you like, so we know who's been doing what to which file, and so we can go back to that person and say, right, okay, on this particular day, you did this, can you remember, or can you add to the information that's already there? And then the final part of that, if we click on one of the drop downs here, is that we will see a whole bunch of benefits that the whole system can do by bringing all that information together. And that is all sorts of things, like we can print out the appointment letter and send that to you, because this system will also manage appointments as well. And it will eventually we'll be able to show the management plans for each individual as well. But very importantly, it also allows us on the day for each individual to input their summary of the consultation they had with you, and then at the click of a button, print a clinical summary letter, such as the one shown here, which has all the component parts. And that should get out to you a lot quicker than it has been previously. To that, we will also add the results of the blood investigations as well. So this is just the first step, and we're building other components that will come in future years. In particular, things like voice recognition software. Already we're using tablet computers to be able to access this information and put it all in there in the clinics. And but we hope that there will be other things that we might be able to incorporate in the future, such as what are called wearable sensors. So you've all anyone heard of Fitbit and those kind of things? Well, that's rubbish, but there's much better stuff out there. for measuring, you know, your daily activity, how much you're sleeping at night, who's getting up in the middle of the night. If you're getting up in the middle of the night, what are you doing up in the middle of the night? Are you going for a pee, or are you going to, you know, Google something? So, you know, all of that kind of information stitched together will give us a much better view of how we might be able to help you in managing having BBS, because we know sleep is a real issue, not just for me. So, and one thing I want to say, and it's just, I'm showing you here the cover of a book by an American physician called Eric Topol, and it's called The Patient Will See You Now. The future of medicine is in your hands. And all I simply want to say is that there's never been a time in the NHS or in healthcare in general whereby the patients themselves have been so empowered. And you as a group are no exception, and you need to make sure that you grasp all these opportunities with both hands and both feet, and make sure that you know, the NHS listens to what you have to say, and we can discuss that later on. Okay, so I'm moving on to some information and updates about the genetic testing. So if you remember, those of you who have been coming to this conference for a decade now or so, we hadn't identified the first gene until the year 2000. And then it was a slow trickle after that. But now, as I said earlier, we're now up to 21 genes. And therefore, we've now been able to move this test into the NHS. And so Beth Hoskins is here, and she has single-handedly more or less set up this particular service, which, as I say, is a major support service for the UK. So it's a reference centre. And so the figures are quite simple. We've now completed around 692 tests. 419 of these are patients, 74 are patients that can actually, you know, the primary patient who comes to the clinic, and 74 of those are their affected relatives, other people in the family. So diagnosis is actually confirmed overall using this test now in about 80% of you. So that's a major, major advance. So the reason I say that is because we're seeing more and more people now who are sitting on the fence. So when it comes to us trying to make a clinical diagnosis, we're sort of going, we think there are some things that you may have that might say you've got BBS, but you might not. So having a genetic test actually helps to confirm that suspicion, if you like. So 80% for a diagnostic test is a significant advance for any genetic disease. But as I say, there are still 20% yet to be solved. We've also been able to provide a significant number of carrier tests, because if you find a gene for a particular disease, it also means in this type of condition, where you have to have two genes to actually get the condition, what's called autosomal recessive. Some of you will remember that from the early days of your clinic visits. It means that people who are carriers will have one copy of that particular gene, and there'll be many people in the family who have that, and they may want to know the reasons, well, they may have several reasons for wanting to know whether they're carriers for family planning purposes and so forth. So we've been able to provide just under 200 of those tests now, so that's a major advantage. And then the last portion of tests are what we call predictive tests or prenatal tests, so unborn baby tests, and we've been able to successfully implement 22 of those using this system. And the breakdown, which we are always interested in, and that'll become more obvious later on, is that as we know, and we've said previously, but for those of you who are probably new to the meeting, the two genes that are probably the most, what we call prevalent, so in other words, more people in the UK have mutations, so spelling errors in the gene for BBS1 and for BBS10, okay? But we know, all of you, we know exactly which one you are, and most of you should also know which one you are, and that will be very important for later on when it comes to potential treatments and things like that. Right, so we'll move on to the sort of scientific, a couple of scientific highlights, should I say. And we're still, what we do is we make sure that we report our scientific findings to the international community. And many of you were involved back in 2012 with the very first international scientific conference called, imaginatively, Cilia 2012. And that was held at our institute at the Institute of Child Health next to Great Ormond Street Hospital back then. And it was well oversubscribed at the time. We didn't think that many people would come because it was a new conference. Well over 300 people came, and we had a waiting list of 50 people. Since then, we've been to 2014. We went to Paris, and then just last year we went to Amsterdam. You all know what Amsterdam's famous for, tulips, and so in between, actually most of the time we were at the conference, and but the conference was amazingly attended by people from across the world, and the scientific advancements in the whole of the cilia world are really escalating. So that's our sort of general outlet. The next one will be in Copenhagen in 2018. So just one highlight from some of the work coming from our lab. This is work from one of our PhD students, Rosie Davis, and she has been working with the bits of skin that many of you have been very kind to donate. And I don't mean dandruff. I'm talking about the skin that we have come at you in clinic. Mainly Elizabeth and I have cajoled some of you into giving a little punch biopsy of skin from your upper shoulder here, which doesn't cause any major scarring, you'll be pleased to know, but has been immensely beneficial in helping us to understand more about how BBS occurs, what are the mechanisms of disease, and also developing the resources that might be helpful later on for looking at treatments and things like that. So what has Rosie been doing? Well, the picture here shows that after we've taken the skin biopsy, what happens is we grow the cells in a dish in the lab, and then what she's been able to do, and this is like science fiction to my mind, she's been able to grow little baby eyeballs in the dish. And so these are what are called optic vesicles that I'm showing here. They don't look like very much, but believe me, that within these sort of circular structures, these sphere-like structures, they actually have all the elements of an eye. So what we are able to do, what she's been able to do, is to actually take a very close look at some of the layers of the back of the retina. So the retina is obviously the part of the back of the eye that receives the light, and remember the photoreceptors are there, and we can use different colored labels to have a look to see whether all the parts should be there. And sure enough, after 98 days of culturing these cells, looking after them like babies, we can see that all the elements are there of the photoreceptors and other layers of the retina, which is absolutely amazing. She's then moved that on even further to another 196 days, another 100 days, and she's been able to show that actually there are, in this particular instance, there's a cone there. So you remember there are the rods and the cones that make up the photoreceptors at the back of the eye. Well, there's actually a cone there. Whether it's actually working or not, we don't know. That's the next step to do. But when we look very closely with an ultra-high powered microscope called an electron microscope, we can actually see all the component parts of that photoreceptor. And what I'm showing here is a cell which has a big fat bottom to it with a narrow neck and then a big bulbous part at the top. The bulbous part at the top is the part that collects light in the photoreceptor, and the bottom part is where the nucleus and all the proteins are made and all that kind of thing. So we're at the point now where we now have been able to show that we're able to take from a piece of skin turn that into an eyeball in the dish. I'm happy to discuss later on how we do that. That, to my mind, is science fiction that's become science fact. But the beauty is that we should be able to use this system, one, to determine what is going wrong, why are people going blind, because we can't get bits of eyeball, it's not possible, and they don't grow anyway. But this system will be able to help us work that out eventually. Okay, the other bit of work is from another PhD student in our lab, Katia. And Katia has been working on all the yummy urine that you've been giving us. So that is something from which she has had the enviable task of dragging down the cells that are in there and throwing away the liquid. And then she's mastered a protocol, a system, to grow those cells in the dish, in the lab. And then what she's been able to do, it doesn't show very well, I'm afraid, because of the lighting, but we want to compare them to people who don't have BBS. So some of us in the lab have also donated our wee, so it's not just you, it's us as well. And we want to see what does it look like if we make these cells into a ball of cells, what are called spheroids. Because these cells, if you treat them in the right way, will automatically form like a football, if you like, or a football of cells. And the typical football of cells for someone who doesn't have BBS is maybe somewhere between 10, 20, maybe 30 different cells. And they form a cavity, just like a football in the middle. And into that cavity are these cilia, these little finger-like projections that are coming off the top of the cells. You've heard about those, we've previously talked about those. And so that's what a typical spheroid, as we call them, looks like. However, when we looked at several patients who have BBS, they all look funky. So in other words, they've all got very strange appearances. Some of them will have, well, most of them actually have hundreds of cells instead of just having, 10 to 20, 30 cells or what have you. There are some abnormalities in the length of the cilia, for example, that's poking into those. And what we're trying to do is to determine whether there is a particular pattern that goes with the type of gene that happens to be involved in an individual, which gene is mutated. And that, again, is providing us with the resources to be able to understand how does the kidney disease arise in BBS. And secondly, it gives us something to work with that when medications and drugs become available, we can use this system to test those to see whether they can actually convert the abnormal cells that you're seeing on the left-hand side, the abnormal spheres or footballs, into what should be the smaller, tighter form that's associated with not having BBS. Right, I'm just going to finish up really just talking very briefly about where we are with the opportunities around treatment. And simply to say, and I mentioned this very briefly last year, but I want to highlight it again, that industry, pharmaceutical industries, are super interested in BBS. They're interested in lots of rare diseases, and we can go into the reasons why. I don't want to address them now. But in short, we've been having lots of discussions. We've been approached by lots of different pharmaceutical companies, big and small. We've had discussions, I think I mentioned last year, about Pfizer. We've had discussions with GSK. You'll have heard of all of these, Roche. I've had more recent discussions with another Japanese company called Takeda. And last week, I was in Boston speaking to Sanofi Genzyme, who really want to come and speak to us about the potential for doing clinical trials of some sort. I don't know what medicines they have in the pipeline because we haven't signed the confidentiality agreement yet, but that's happening hopefully as we speak. So what I'm saying is that when I got to Boston, I was amazed to find that there is a whole unit at Sanofi Genzyme that is dedicated to BBS. They have 7 senior scientists working on BBS, so they're taking it seriously. But the point is they want to work with you. So you need to really be cognizant of the fact that you need to be part of the negotiations, and I will make sure that you are part of the negotiations as a society, as a group, when it comes to those taking part in those particular trials, if they're appropriate to do so. And again, we can talk about that. And very briefly, the types of therapies that I've mentioned this before, that we're addressing our attentions to are developing things like medicines, tablets or other types of drugs, which we don't expect to be able to cure BBS by any means. We don't expect to be able to cure BBS in total, but manage each of the parts of the disease, if you like. And I think at the end of the day, it's going to be a combination of things like gene therapy and other genetic therapies and various medicines to be able to manage in the future all of the problems that are associated with BBS. And the area where we've been making a lot of progress, and I did mention some of this last year, is around gene therapy. So that's introducing a fully functioning version of the faulty gene back into an individual to make it work in the right tissues, say in the eye, for example. So work that Victor Hernandez has been doing with his team in my lab. He apologizes, by the way, he's at another conference and he was hoping to get here today to do some more introductions around this particular study, but he promised next year he will come. But essentially, we've been using mice. So mice that have BBS, they have all the same problems. They're overweight. They have some of the behavioral anxiety issues that Sarah talked about this morning, and they have visual impairment. So they're a perfect model for us, almost perfect model for us to look at. And so he's been doing gene therapy, introducing a human BBS1 gene, so a fully functioning BBS1 gene, back into the eye of those mice, into one of those eyes, but not into the other eye. And there's this when just after they're born, and the eye in which it's treated, we're about 9-10 months now after treatment, they can still see out of that eye that's been treated, but the other eye that hasn't been treated has deteriorated. So that's very promising. And so essentially, because BBS is a multi-organ system, it affects different organs, we don't want to stop there just at the eye. We want to see whether we can go to other parts of the body. And so I'm really pleased to announce that just a few weeks ago we signed a deal with a funding agency called Apollo Therapeutics, and I can go into the details, I won't now, about what that is. It's a much better system or funding system than, say, going in with a single drug company. It's several drug companies that have put together a fund that we applied for, and we're the first research group at UCL that have been given money to actually develop the gene therapy program. And the nice thing is that not only will it allow us to do what we call the preclinical bit, which is all the animal studies, prove that they all work and that it's all safe, but they've also promised us that we will be able to go to the clinical trials as well, and they will look toward funding those as well. So that's really quite promising. I'm not going to touch on this because the sort of the cognitive and the exercise parts Elizabeth's going to tell us about shortly. But I am going to just finish up by saying to you that I've looked at some of the last talks back to about 2000 that I've given at this particular conference to look at some of the advancements, and I've been absolutely overwhelmed by the amount of interaction that you guys have had. I've known this anyway, but when you see it on the page, it's absolutely astounding. So if we go back to 1999, 109 of you took part in the first paper, the first and one of the largest surveys to date, which indicated what the diagnostic criteria for BBS should be. And I'm proud to say that, you know, this many years later, we're still it's still held up, that paper is still held up as the main diagnostic criteria in clinics all around the world for making a diagnosis of BBS. And you know, it was you're taking part in filling out those surveys way back when. Back in 2000, we found the first gene for Bardet-Biedl syndrome, but it was then it was in 2003 that we found the first gene in one of the families that used to come to this conference on a regular basis. That gave us the first clue that cilia were involved, and we haven't looked back ever since then. In 2004, we were able to determine that that several people have hearing impairment as well, and why that is as well, and you took part in many of those. And in 2005, in a study where we, as I told you, we look at mice, we make mice that have BBS to be able to study them, we were, in a reverse way, able to see that there were problems with the ability of mice to actually smell. And we thought, well, this is strange, none of you had complained about that. So when we went back to the clinic and asked you that using a scratch and sniff test, 60% of you said, yeah, you have problems with the ability to smell. So that, again, was a major interaction. We've done previously some of the preliminary studies, and some of you have taken part again in memory studies at this particular conference. We started that back in 2009. That was the first indication there were problems. 2010, as you've heard, the clinic started. 2011, the genetic test system started. And 2015, we came at you for more samples, skin biopsies in this particular instance. And 2016, the Society has now produced the second version, a much more updated, comprehensive version of the medical booklet. So you no longer have to spend 20 minutes explaining to your physician what BBS is, you can just give them the booklet. And obviously we've been milking you for urine. That didn't sound very good, did it? And again, Elizabeth will tell you about the MRI studies. So thank you very much. I hope you're going to carry on partaking in the studies that we always come at you with, because it makes a huge difference to the scientific community and ultimately to you guys. And I want to thank Julie in particular, who's stepping down from the clinic, for all her sterling work all of these years, helping to set those clinics up, and we'll miss you a lot. Thank you.